Hello, everyone. Today, we are diving into an exciting technology we've been hearing everywhere that's transforming the generative AI world: Retrieval-Augmented Generation, or RAG. I have my colleague Tomomi with me. Hi, Tomomi.
Hey,
Tomomi will break down what RAG is all about by doodling.
that's right. So let me walk you through the concept first. So let's get started. Retrieval Augmented Generation, or RAG, is a way for AI to pull in information from a variety of data sources outside of its training data to give better and more informed responses. Imagine you're writing a science fiction story about a distant planet, but instead of making it all up, you have a magical library that contains lots of books, research papers, and everything about the universe. That's how RAG feels. It combines the creativity of generative AI with the depth of existing knowledge. So retrieval is when the user asks about this planet. AI goes into this library and it pulls out books about planets, stars, and space travel to gather information. Once the relevant information is retrieved, the AI synthesizes this information, combining it with its own generative capabilities to craft a story. This is the augmented generation part. Well, in reality, when you build a RAG-based app, the data source can be a collection of plain text, or the data come from an API, or structured database, or it can be an index data from a vector search.
This is incredible, Tomomi. Now, let's take this concept from the drawing to the digital world.
Thank you. And I'm so excited to see this in action. So, over to you, Ayca.
Let's start coding. In this demo, we will use pre-release version of Teams Toolkit. We will create custom Copilot with Azure AI Search using Python. I will select custom Copilot, chat with your data, and Azure AI Search. Let's select Python, Azure OpenAI. I already created AI Search service and OpenAI service on Azure. Let's go to OpenAI service, go to keys and endpoint, copy the key, and paste it. Let's go grab our endpoint as well. I will paste it. And we will need the deployment name. Let's go to model deployments, manage deployments, and it will direct us to Azure AI Studio. I already created a model. It is GPT-35 Turbo. Let's select the default folder and give our app a name, space AI Search. Just like Tomomi's doodles, we will create a search experience using Python to find out more about space. Let's start with the configuration. I will open the command box and select Python create environment. I will select the virtual environment, Python version. Let's select the requirements, and our environment is ready. Let's go and update the environment variables so we have all the information needed to run this app. I will use the test tool to run this app. Let's see, we have embedding deployment missing. I already created the text embedding ADA deployment for this. Let's type the name. And let's go to Azure AI Search and grab the key and endpoint for this. So I will copy the endpoint, paste it here, and I will go to keys and copy the key here as well. Alright, after the configuration, next step for us is creating the index and uploading the documents to Azure AI Search. We will use the setup.py script for this. Let's go and have a look. Under the indexers folder, first we have the data folder. We have some example files for Contoso Electronics here, but we will replace all of them with some space documentation. To read these documents and convert them to embeddings, we have getData.py file. This is currently written for reading markdown files. We will need to read PDF files, so I will replace the code written here. As you can see, we have the file names, which are the exact same names with the PDF files. We are using PyPDF2, so I'm going to import this as well. And quickly, let's install it here too. Pip install PyPDF2. What this function does is we retrieve the raw description from each PDF file, create a doc for each file with ID, title, description, and we also create description vector using embedding vector function. That means we are actually doing vector search here. In setup, we get the data, then we create the index if index doesn't exist, And finally, we send the embeddings to Azure AI Search. Let's change index name from Contoso Electronics to Space Facts Index. Let's run the setup py, and let's check if our documentations are under the indexes. There we go, we have Space Facts Index, and if we hit search very quickly, we will see that each document is created. Our final step in this demo is chatting with our data. Let's go to bot.py, and let me quickly walk you through. We're using OpenAI model with Azure OpenAI model options. We have Prompt Manager that helps us manage the prompts. Under the prompts folder, we have chat prompt. In the config.json, you can see the data source as Azure AI Search. And inside the prompt text, as we are talking about the space search, I will update this prompt and make an AI assistant that can help us get more information about space. Let's go back to bot.py. And here, inside our prompts, we add data source. And our data source is Azure AI Search, as you know. I will update the index name as our index name is Space Facts Index. And finally, we are ready to run the app. I will go to Teams Toolkit, select Test Tool, and debug. This will pop up the Teams App Test Tool in our browser. I can ask, tell me about Venice. And I can see we have a lot of information from our document. I can ask about Neptune. And we have some emojis. We also have fun fact. Let's ask, I'm interested in learning about space travel. And we have some information about space travel and fun fact about that too. Of course, our custom Copilot gets all this information from our PDF files. If you want to test this out for your own scenario, you can replace the space documentation with your enterprise data. And that wraps up our introduction to RAG. The possibilities are endless, and we've just showed the basics.
Exactly. So we encourage you to explore and experiment with these tools on your own project. So bye for now and see you in our next video.
Bye!